Morning, I am Dr. Usha Rani, Professor S&S Department R&D Engineering College. I am going to present about the topic of magnetic circuits. In the magnetic circuit, if they are asking magnetizing current required, means we have to work out from the ampere turns. Ampere turns required, if you know, we can divide that by number of turns. So I have taken a formula of ampere turns required as H into L divided by N. If you take, we can find the magnetizing current. I have taken a question of an iron ring of cross-sectional area 6 cm square is wound with a wire of 100 turns and has a saw cut of 2 mm. Calculate the magnetizing current required to produce a flux of 0.1 milliweber if mean length of magnetic path is 30 cm and relative permeability of iron as 470. Here in this question, they have given an iron ring, the cross-sectional area is 6 cm square and the number of turns is 100, has a saw cut of 2 mm means the air gap. They are given the air gap length as 2 mm and flux value is 0.1 milliweber and the length of magnetic path is 30 cm. Mu r of iron is given, mu r of this air gap is 1. So by seeing this question, we can find I as total ampere turn required divided by n number of turns. For total ampere turns required as, actually we can take ampere turns required for iron path of the ring as well as ampere turn required for the air gap. Okay. Here the general formula as from the flux formula in respect of mmf divided by reluctance, ampere turns divided by reluctance formula is L divided by A mu naught mu r. Or ampere turns required means we have to cross multiply phi into L divided by A mu naught mu r. Or we can take pi by A separately and L divided by mu naught mu r. Or pi by A as your flux density. So I have substituted instead of phi by A B. So B divided by mu naught mu r into L. What is B by mu naught mu r as H, magnetic field strength. So H into L. So ampere turns required formula is H into L. So ampere turns required for any path is field strength H in that part into length of that part. So for this question, they are asking magnetizing current. So which is total ampere turns required divided by n number of turns. So this is the given data. I have drawn the iron ring which is having a length of 30 cm and air gap length they have given us 2 mm. Number of turns 100, flux value is 0.1 milliweber and mu r for the iron path is 470, area 6 cm square. So actually we are going to find out ampere turn required for iron path and ampere turn required for air gap. If you add these two, we will be getting the total ampere turns. Total ampere turns divided by number of turns n 100 means we can find the I value. Here we are assuming flux density in the air gap is equal to flux density in the core. So for that the flux density, we have substituted the formula of phi by A. So phi value given as 0.1 milliweber. So I have converted that into Weber. 0.1 into 10 power minus 3 divided by area given as 6 cm square. Convert that into meter square. So 6 into 10 power minus 4. The answer for flux density is 0.167 Weber per meter square. First I have taken the iron path. So I am working out the ampere turn required for that path, which is equal to field strength Hi into Li. Hi formula is B divided by mu naught mu r into Li. So Li for the iron path is 30 cm So I converted that into meter 0.3 and I have substituted the value of B value as 0.167 divided by mu naught value 4 pi into 10 power minus 7. Mu r given in the question as 470 for the iron path. I have substituted. So the ampere turn required for iron path is 84.83 ampere turn. Here next we have to find out ampere turn required for the air gap. So the formula is again H into L, that is B by mu naught instead of mu r value. Here mu r for air gap is 1. So I have substituted only mu naught. So B by mu naught mu r general formula, mu r for air gap is 1 into length of the air gap is given as 2 mm. So Lg as into meter means 2 into 10 power minus 3. So after substituting B, mu naught and Lg value, the result is 265.8 ampere turns. By seeing these two values, what is the inference here is there is more ampere turns required for flux through the air gap to produce magnetic flux through the air gap. Okay, more ampere turns are required to produce magnetic flux through the 2 mm of air gap. By seeing the values, 265.8 ampere turns is required when compared to ampere turns required for iron path. Why this value is too high means because of reluctance of air value is more than that of air gap. Okay, because mu r here is 1, so reluctance value as more value in case of air gap when compared to ampere turns. That's why ampere turns required for air gap is more. So now we are going to add these two. Total ampere turns as ampere turns required for iron path plus ampere turns required for air gap. So I am adding this two. The answer is 350.63 ampere turns. So I am substituting in the formula of magnetizing current. I is equal to H into L divided by N. So H into L total ampere turns is 350.63 divided by number of turns is 100. So the current required is 3.51 amps. Thank you.